right, hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump right into it. This is a word problem on related rates, so Calc 1, and let's look at it. A truck is heading due north at 60 miles per hour, while a car leaves from the same spot, traveling due east at 80 miles per hour. In 10 minutes, what is the change in position between the truck and the car in miles per hour? So, you know what they say, a picture's worth 1,000 words. So let's draw a picture. We have a truck going north. So the truck is going north and it's going at 60 miles per hour. So its rate, or its, we'll call it, we'll say dr dt. So that's its rate. That's how fast it's traveling. So that's in miles per hour. And then we're having a car leaving from the same spot going due east, and it's going at 80 miles per hour. So 80, and we'll call this dc dt, dc for car. I wouldn't call the other one dt dt because then the dt's would cancel. So we're going to call it dr dt. R is the second letter in truck. Just, because. So those are the rates. In 10 minutes, what is the change in position? Well, if we want the change in position, then that would be the straight line distance. So that would be here, and that would be the straight line change in position. So we'll call that dp dt, change in position of p. So change in position with respect to time. Okay, so if we're going at 60 miles per hour, 60 miles in 1 hour, and actually let's put this over here. So 60 miles in 1 hour. If we want to know how far we're traveling in minutes, we need to convert to minutes. 1 hour is 60 minutes, right? So that's a mile a minute. So that means in 10 minutes, we'll have traveled 10 miles. So 10 miles is how far the truck is due north. Okay, then we do the same thing for the other one. So that's going to be 80 miles per hour. 1 hour is 60 minutes. This time it won't cancel out completely and make 1, but it will simplify it quite a bit still. The zeros cancel, and then 8 and 6 both divide by 2. So we have 4/3. And then we're going to multiply that by 10 minutes. This one's not going to be as nice of a number. So that's going to end up being 40/3. 40/3 miles. Okay. So those are our actual positions in 10 minutes. And we need to know what is the position between them in 10 minutes as well, before we can jump into figuring out the change in position. So if we make this into a right triangle, we can use Pythagorean theorem. A squared plus b squared equals c squared. Right? A is the truck, which we're calling R. B is the car, which we're calling C. And then our hypotenuse is the change in position, which we're calling P. Okay, so we just found out that the distance the truck has traveled in 10 minutes is 10 miles. The position the car has changed is 40/3 miles, and then that would be equal to p squared. So then that's 100 plus 1600 ninths is equal to p squared. That's over 1, so I can say that's 900, or sorry, multiply by 9. So yeah, 900 over 9. 900 plus 1600 is 2500 over 9 equal to p squared. Then we can square root both sides. So the position between the car and the truck is going to be the square root of 2500, so 50, over the square root of 9, which is 3. So the position between the car and the truck is 50 over 3 miles. So now that we have that, we can figure out the change in position between the car and the truck. So we're actually going to go back to Pythagorean theorem. A squared plus b squared equals c squared. And then we're going to rewrite it in terms of r and c and p again. So change in position of the truck, the car, and then the overall position between the two vehicles. And then what we're going to do is we're going to take the derivative of this equation with respect to time. So then that would be 2r, and then dr dt, I'm just going to call that r prime, 2c, and then dc dt, I'm going to call c prime, and then 2p, and then dp dt, we're going to call p prime. Now p prime is actually what we're trying to solve for. So we should be able to plug everything else in. Also notice that when you take the derivative of a Pythagorean theorem equation, those 2's can just cancel. So I end up with just r prime plus cc prime plus equals p prime. Or if you're doing just in terms of a, b, and c, then it would be all of that, but with a, b, and c. So now, this is why we had to do all of that earlier. We know r, the position of the truck, it is 10. And the change in position is 60. Then for the car's position is 40 thirds. Its change in position is 80. And then for P, we found out that was 50 thirds. And we're trying to find its change in position. Okay. So then that's going to be 600 plus, then that's 8 times 4 is 32. 3200 thirds is equal to, and then that's just going to be 50 thirds P. I'm going to times everything by 3 to get rid of the fraction. So I'm actually going to do that all in one step. So that way I'm saving a little bit of space here. So I don't have to shift the board around. So we got this. And now we can simplify it down a little bit. Now let's go ahead and add these as well. So that's going to be 8 and 2 make 10. 0, 0, 0. 3, 1 make 4. 1 more make 5. So actually this ends up working out pretty well, because then we can just divide by 50 and get 100. So P prime is what I meant to have. I wrote that as P. So P prime is 100, meaning that the change in rate is going to be 100 miles per hour between the car and the truck. All right, I hope that's been helpful. If you want to see the 5 math mistakes everyone makes and how to avoid them, it's a free PDF guide on my website, myersmathematics.com. Link in the description below. And I'll catch you all in the next video. Blessings.